Hello, everyone, and welcome. I'm really glad to be at your conference. We have so much to talk about, so I'll just begin. In the presentation, I will present a solution where we can reuse our functional WebDriver test for wall testing. So I guess you read who am I. I'm most famous with my blogging at Automate the Planet. I wrote a few books, and yeah, very often I talk to conferences. So what we'll talk about, first we'll discuss our problem. Then I will present different tools that we usually use when we need to do wall testing in a couple of issues with them. Then we'll talk about the benefits of, reusing the functional tests and combining them for wall testing. And the biggest part of the presentation basically will be, the technical part where I will show a lot of code. So let's begin. What is the problem? First, imagine that we have the following site. This is a demo website. Imagine that we have an online shopping cart where we can create purchases, basically. Here we purchase rockets. I can add a rocket to the cart. I can apply discount codes. As you can see, everything is asynchronous using latex technologies. It's not reloading the whole page. I can increase the quantity, fully functional online shopping cart. I can fill the information here. And we can do, in the functional testing, we can check whether everything is working properly, whether the prices are okay, whether the coupon is applied, when we place the order, whether the order is in the account, and so on. And then the second thing is that we want to have wall tests for this particular solution. So what is the wall test? I guess most of you know, but if I need to recall, this is a non-functional type of testing where we execute simultaneously different scenarios against our website in order to test the behavior under certain wall. Some popular tools, here I listed few of them, that we usually use for wall testing. Maybe the most famous one is Gmeter. In my professional career, since I come from the Microsoft world, we used a lot Visual Studio for wall testing, but it was deprecated like a year or two ago. So we had to switch. Most of these tools are UI based, meaning that they basically you press a record button, you perform your use case, the tool is recording all of the requests, and then you can basically, through a certain configuration in the tool, reproduce them with the vault. What are the problems with them? Usually, I haven't used all of them, but I use some of them. So some of the problems, especially this was the case with Visual Studio, is that these tests get out of date quite fast, and they are really hard to maintain. I mean, if there are changes in the workflow, imagine that, I don't know, we add additional discount or we change the locators of the elements, we had to fix some of the things in the wall test, but some of these tools are quite hard to do that. Some of them allow you to export the code. This was the case with Visual Studio, but the code was really hard to understand, and a lot of code there. Another thing is that usually these tools, most of them, you can do some complex things, but for example, imagine that we want to create a wall test for this online shopping cart, but instead of every time creating a purchase with the same email and user, we want every single thread to use a unique email and a password, so that when we go to your account and check the order, be sure that there is only one order. In some of these WOW test tools, this is really hard to do. It's doable, but again, you need to read about how to do it. Then most of them, like not all of them, but most of them lack of advanced verifications. Usually, you can check the statuses of the requests, whether they are okay or not. You can check whether there are some errors and exceptions when you do a lot of requests. If you want to check particular message, whether it is there or not, at least in Visual Studio, for example, you couldn't do like this proper search for elements like in WebDriver, but instead you usually just check for a particular text, whether it's in the HTML or not, which is like not so, yeah, it's also. And when you have these two sets of tests, the UI tests and the WOW tests, you need to maintain both of them. This was the case with my team back in the days. So it's more expensive. And then depending on the tool, for example, for Visual Studio, there were really high licensing costs. Like in order to use them, to use it, we needed Visual Studio Enterprise, and then WOW testing agents. Later, they changed it to pay for WOW testing minutes in the cloud. And as you can imagine, the bill gets really high. So what are the benefits of the solution that I will propose of combining and reusing WebDriver tests for WOW testing? First, you basically reuse your tests, so you can get quite fast without, researching new technologies and tools. You don't need to switch to learn the new tool scripting language, because when Visual Studio for WOW testing was deprecated, my team had to learn how to use JMeter with code, but there in Gatling, and there this is Java-like syntax, but we come from the .NET world, so it was a bit hard for us. Then if you use the proper test automation framework, usually WebDriver tests are much more maintainable compared to these WOW tests. In the solution that I will propose, we will reuse most of the verifications, which is really cool. And we'll be able to do some complex verifications. And since it's open source and free, the only cost that you have is basically when you use open source is that you need to maintain the code. That's it. So let's jump right in and show you the code because it's a lot. First, I will present some design patterns from my book, and I will use some of the, all of the code of the presentation, but in order to understand the solution, you need to get what this pattern is used for. Here I created a simple test in a single file, first version. This is, by the way, chapter 2 from the book, where I explain how to stabilize the tests. Here I wrote a test using the worst possible, practices, meaning I directly put everything inside the test, like finding the elements, clicking on them, typing text, everything. But the worst part is that in order to handle these asynchronous parts with the loading screen, I use these hard-coded pauses. Here we wait for half a second, here we wait for 2 more seconds, 2 more, and to the end of the test, we basically wait for 20 seconds, which is really, bad. And this is not all. Sometimes this time will be enough, but the next time, if the website gets slower, you may need 3 seconds in order to pass the test. This means that this will become a flaky test, meaning a test that sometimes passes, sometimes not. One solution might be just to increase to maximum these pauses, for example, placing here 5 seconds. But this means that, for example, if this message appears on the first second, we'll waste 4 seconds waiting for something that is already there, which will make our test really slow. One way to fix it before going into the decorator is to create helper functions like this. Just ignore the name, it's not important, but we use this special class called WebDriver wait. We use this special class WebDriver wait, or the so-called, I think, fluent wait in Java. Basically, we will wait until the element is there. Immediately when it's there, we will return it here. And this way, here I removed all of the pauses and used directly this helper method, which is great. This is one way to do it. And let's now check what the decorator is. Basically, the decorator is something like a wrapper. It has 2 functions. It really helps to follow more closely the solid principles. I'm not going to talk about them, but the main thing that we strive is to, when we have a logic, when we want to extend our driver or element, instead of just going to the existing code, we are able to extend it through new classes instead of editing the existing code. That's the main usefulness of the pattern. And the second thing is that we can change a little bit the API, as you'll see in a minute. For example, naming some of the methods better. For example, in our solution, instead of using send keys for typing, we have a better method name called type text. So how it works, we have a base class of the component. In our case, this will be one component will be the driver, and the second component will be the element itself. The concrete components will be basically the implementations of the WebDriver and the element. Then we have one base class for the decorator, and as you can see, the decorator basically uses composition. The composition means that instead of using inheritance, we are just placing the wrapped component or object as a variable, as you will see in a minute. And in the decorators, the decorator basically adds the new behavior. In this method A, which is part of our core interface, we execute the component wrapped object, for example, type text. Here we have the same method called type text. We use the original implementation called, for example, element type text, and then we add the additional behavior. In our examples, we'll add, for example, logging before typing or after typing. So let's check how this looks like. Here we have this is the interface of the component of our driver. I removed some of the methods because we don't need them. We have a start, which will initialize the driver, and we have find element and find elements. That's it. We have the same component class for the element. The new thing here, as I said, we changed a little bit the interface, is that, if you want, I can zoom a little bit. I changed the interface a bit. As I said, here we have this type text, and I added a new getter or a property in C# that the element will know how it's located, which is really cool. So in the concrete implementation of the driver, here it is. Here is our wrapped driver. This is our concrete component. We implement this base class, the driver of the component. We have one, this is another pattern called factory method, where we pass the type of the browser as enumeration. And this is how we initialize the driver. But this is not so important. The important part is here that I want to show you in this find element. It's similar API to the one that native WebDriver provides, because we accept here the by locator, but instead of returning web element interface, this one that comes from WebDriver, we're returning our base element component. And as you can see, the magic here is that first we use explicit wait to wait for the element to appear. Then we create our concrete component, the web element, and then we wrap it into the decorator. This is our decorator for the element, the walk element, which basically accepts the concrete component, the element class. And as I said, first we add the new logic here. This is the logging. We basically type to the console what we do, what text we type, and then we call the text property and so on. And if we look into the tests right now, here I create the same decorator for the driver, then initialize the concrete driver here, the WebDriver. We use this factory method to start the browser. And if we look closely to the tests, here this looks really the same, like the first test here with the pauses, but actually here we are calling our, if I hover, you will see that this comes from my decorator, a concrete component. Basically, this find element will first wait for the element to appear, and then it will be returned. And here we use the improved API, since this is not the native WebDriver element, but our decorated element that we use the type text. And we removed all of the pauses. If you want to add additional behavior, we will basically create one more decorator instead of just going directly and edit the existing code. So this was the decorator. You will see in a minute why I explained it, because we use it heavily in the wall testing solution that I will propose. So now I won't be able to explain every single file from the wall testing engine, since it's a lot of complicated code and it's a lot. However, I will try to give you a high-level overview of the whole algorithm and architecture, and we'll take a closer look to the different important modules. Here are a few of them. First, we'll capture the HTTP traffic to a proxy service. Then we'll have a logic for saving this information, like all of the requests information, what assertions we do, how we locate the elements that we need to verify, what we need to verify in the elements, and so on. We'll save this information to a JSON file. Later on, we'll have a separate test for the wall tests that will reuse these JSON files. And these JSON files, they will be always up to date, because every time you execute your test, they will be updated, which is really great. You don't need to worry about, maintaining every time and re-recording. Then we have this wall testing generation engine. This is the class responsible for creating the multiple threads. Then we need this special verification engine. Basically, when the response is returned with the HTML, we need a logic for loading into the memory the HTML DOM, and then searching for the elements and make the same assertions as in WebDriver, since we don't have a browser. And lastly, we need the report engine to create an HTML report with everything I will show you in a minute. Two things. At the end of the slides, you will find a lot of useful resources. This wall testing solution was and it is part of the open source framework that I developed called Bellatrix. I won't present the demos from here directly, because this is a really huge solution. You can download the whole source code for free. But here, as you can see, there are so many features and stuff. There are almost 120 projects. This is why, especially for the conference, I created a minimized version of the whole solution only for the wall testing with the decorator and all this stuff. Again, you'll find at the end of the slides a link to the GitHub repo where you can download and play with this. So yeah, you'll have access to it. So let's check what we want to do part by part. First, this is the same, almost the same test that I showed you before, version 3, where we use the decorator. Just some of the names are a little bit different, but that's fine. We want to, our solution, in order to mark a test to be reused for wall testing, I want to place this wall test attribute, and this is how my engine will know whether, you know, to record all of the requests or not. And everything, as you can see, is almost similar. The only difference here is that I added this additional method called ensure text is, instead of using directly MS test assertions. Why is that? Because here, because if we use this asserter equal, WebDriver basically will go directly to check what is it in this text field. But as you saw, some of the messages are loading asynchronously, and sometimes this will fail. This is why this ensure text is, if we look inside, it basically uses again this WebDriver wait class, but this time it will wait for the text to appear for a couple of seconds, which is really great. And also, since this is part of our element decorator, we can add additional logic for storing how the element is located, with what type of locator, for example, XPath, what is the value, what we need to check, and we will use that into the wall testing engine. So this is one of the few changes. One more thing, we have this configuration JSON file, part of our end-to-end test project, where we basically have this section about the wall testing, and we basically mention whether everything is enabled, the default URL, where we want to store this JSON file, some certificates if we need to, if the website is HTTPS, and a few regex expressions if we need to ignore some of the URLs. That's it. Then, when you, in a minute, I will show you the proxy, how we record the, you know, all of the requests. When the test is executed, this type of JSON is created. As you can see, it's really long because it's a long test and we do a lot of requests. Basically here, we save the information about the different URLs that we need to, for example, post to. We store all of the headers, the body, how much time do we need to wait between the different requests, all of that. And maybe some of the interesting part is that in order to support these complex scenarios where we need to, for example, create a data-driven wall test with different emails, we store information about the request modifications or the data we basically type. And about the assertions, in this array here from the JSON, we store all the different assertions. How the element was located through XPath, what is the locator value, the assertion type, ensure text is, and what we need to check in the element. This is the JSON that it's saved. In a minute, I will show how we generate that. And how the wall test looks like. We have a separate project for the wall tests here. We have the same JSON file. Again, wall testing, absolutely the same settings. And in the wall tests, basically this is a unit test where we start the wall testing engine that I will explain at the end. And we need to configure a few settings. The first thing is that we need to mention what type of wall test this is. Whether it's executed for a time, for example, 5 minutes, or a number of times. We can change the mixture mode. If we use equal, this means that if we have 5 scenarios, they will be executed equally. But we can set weights, meaning that some tests will be executed more often than others. Here we configure how many simultaneous processes we need to start. Then here is the time for the test, for example, 2 minutes, 30 seconds. Here we mentioned that we want to simulate the actual timing between the typing and everything, the way WebDriver is doing it. Here we can ignore, again, some URLs through regex expressions. For example, here you can ignore all Yandex Metrica stuff or Facebook pixels and stuff like that. You don't need to load test them. Here we'll mention which tests basically we want to execute. You can use regex expression as well. And finally, here we mention the type of assertions that we want to do. By default, we'll check whether all requests are successfully executed. And with this second method, we'll execute we'll simulate this ensure text this and all of this ensure methods logic again in the load test too. It's really neat how we do it. I'll show you in a minute. And then we just call the execute method and where and how our result should be named. If I need to show you the results, just a second. Here is the sample report. It's all, you know, I'm not a front-ender, so we use just a few open source JavaScript libraries here to create the chart. This is the timing for the different scenarios. We have some tables with search to see all of the requests and the exception messages and the timing, and that's it. So let's check now how this works. If we go to the base test here, as you can see, this is the base test for all of our end-to-end tests. This is in, I created a separate library project called Web Core. Here you can find the different decorators and adapters. Basically, this test initialize will be executed before each test. Here I used only Chrome, that's fine. By the way, in the solution here, I use basically a C# open source library for the proxy service. But in WebDriver 4, we will be able to use DevTools Chrome API to do the same. I wrote an article, free article about it. You can find it on Automate the Planet, basically explaining the same stuff. So basically the thing that we do here is that we start the proxy service. We started it, then we initialize WebDriver proxy and assign to the port that our proxy service is listening. And we start the driver, like again, through the decorator or adapter design pattern. If I go to the proxy service, we use this open source project called Titanium Web Proxy. This is a C# project, basically a C# proxy. The nice thing about it is that it provides a lot of events where basically you can add additional logic that can happen before or after some response request. You can modify requests or block them. You can change them. It's really great. Again, I wrote an article about it. You can just check it if you are interested about it. It's not so important right now to explain it. But basically, we subscribe to this before request event. And as you can see, we have additional class called load testing workflow plugin context. This is important, where this is a class where basically is responsible for storing all of the requests and saving them to the disk. If we open this method here, as you'll see, this is our event handler, or the method that will be executed before each request. A little bit hard syntax, I know. Here we start a new thread asynchronously because, you know, all the requests are happening at the same time. here we do a few checks. The important part is happening right here. We first apply a filter. If we check the filter here, as you can see, we perform these regex matches to see if we need to ignore particular URL or not. And if this everything is okay and we're inside these conditions, the interesting part is here where we store in this particular list the requests. We store them as C# objects, this HTTP request DTO, and then we, as you will see in a minute, we serialize it to JSON later. If we check what this collection is, basically this is a concurrent dictionary or a special C# dictionary that handles multi-threaded code in order to, not deadlocks to occur. Our key is the test name, and basically our value is a concurrent back, which is a multi-threaded list in C# where we store all of the requests. And if we check here the post-test cleanup, this is executed in the test cleanup phase. We basically, the thing that we do is that we check the configuration, we create the folder, and as you can see here, we serialize this concurrent back or basically multi-threaded list to a JSON file, and we save it. That's it. Later on, we use this JSON file that I showed you here, this one, into the wall tests. And how this works, let's see. If I go here and open this wall test engine, this is part of the magic is happening here. We initialize all of the different multi-threaded code and everything and the assertions. In this execute, we do a few things. Here we apply this mixture if the tests are balanced or not, depending on the weights and stuff. Maybe the most interesting part is here the execute for time and execute for number of times. So we do a few things here. This wall testing service do a couple of things. Here we create basically in this create test tasks all of the threads based on a number of processes. We use here the TPL library part of the C#. This is basically the library for multi-threading right now in C#. We use this special class task factory start new. This test body, this action is basically a pointer or a delegate, a pointer to a method. Basically here we provide the method that inside it will perform all of the requests. This is it. And we execute it a number of times. And later on, when we create all of these threads and they are already started, we use this another interesting method called task wait all, where we will wait for all these threads to finish, and then we'll start them again if needed. If we go back one more time, you'll see that here, this is in this execute test scenario, in this local function here, this is the place where in this execute is the place where we execute all of the requests in this test scenario executor. The thing that we do here is that basically, if you see here, we have a for each where we for eaching basically all of the recorded requests in the JSON file. We again check whether we should filter or not based on the regex expressions. And then we basically measure, create the REST request, execute it, measure for how much time it was executed to put it back into the report. And then we come to the almost last part of our solution, how we execute this recorded assertions. We, as you can see, we for each here again through this wall test assertion handlers. What is this? If I return here to my wall test again and go to the wall test engine, and if I scroll down to a little bit more, you will see that we have these two initialize methods. I have initialize wall test locators and initialize ensure handlers. When the response is returned as HTML, we need a library in C# that is responsible for, as I said, basically putting the HTML DOM into the memory and be able to locate elements. So I use a library called HTML Agility Pack. Basically, if I go here to the locator, it uses this HTML document class. Basically, we're saying HTML document load text or load HTML, and it loads everything into memory, and we have HTML DOM into the memory, and we can use the library methods. For example, get element by ID, by name. I can write selectors through XPath to locate the nodes, or these are the particular elements. And then I basically return them in my custom wrapped objects. And then I have my handlers, ensure handlers that we initialize. This is, as you can see here, representation of my ensure text is method. Here I pass as an argument the wall test element that I already is basically a wrapper to this element into the memory. And I have access already to all of the attributes to the inner text and stuff. And as you can see here, this is a simple condition where I just check the inner text of the element, whether it's matched or not. This is how this assertion is happening into memory, which is really great. After that, we return this assertion results, and we use it later to the report. And lastly, how we generate the report, we have this load test report generator class. Basically, we have an HTML here embedded into the project. As you can see, this is the template. And I have these placeholders where basically when I load this as a string, I basically replace these placeholders with the HTML and JavaScript that I generated in these two methods. Here, based on my load test results, I generate the body of these tables that I showed you before with the search through a string builder class. And then I do a similar thing for generating the JavaScript, basically this all of the JavaScript code for these charts that you saw before. And I just replace them into, I replace this place. Then you can download the minimized version of the framework only about the load testing part from this URL here. And let's now check some of the questions. Have you used Vocus for load tests? No, I haven't, but I will definitely check it and see, what is it. About the information, one of the question is, do I have any tutorials to read in detail? Yesterday, my last article, with my last article on Automate the Planet, I started new series about custom test automation frameworks, and I plan to write a new book about this topic, but everything will be completely freely available on Automate the Planet. And each week I will add a new feature and explanation, like this is one of the features, for example, for the wall tests. And so just check the blog regularly or subscribe. And I think soon I will write a detailed article about every piece of it, because as you saw, it's really complex. And yeah, you can just drop me a line on LinkedIn and I'll be happy to chat and to help. And there was this third question. How do you think if this solution can completely replace load and performance testing? I'm not completely sure. Like, I really like it. But as you can guess, my team is a small team. Our company only 5 people. We use it only as a feature in our framework. But as you can imagine, tools like Gmeter or Gatling, they are built from whole communities, a lot of people, and they have many features inside them. This is why I'm presenting the idea to the community and everywhere, so that we can build it together, you know, because it's free, it's open source, and probably some of you may get inspired and help me with it, or create even something better with the idea. But maybe this is the future, you know. I really like the idea that all of the things should happen through code. I don't like the idea about these UI tools, you know. It's something like 15 years ago. So yeah, I think these were all of the questions. Thank you for watching. I really hope that next time we will see each other face to face on site. But even like this, thank you for the invite. And yeah, see you soon. Thank you. And if you have any other questions, don't hesitate just to write me directly on Automate the Planet, or just drop me a line on LinkedIn, and I'll be happy to help you with anything. Thank you.